amplifier. So I am neglecting these two capacitance in the equivalent diagram. So this is the final equivalent diagram you see. Vs, Rs, RB dash E, RB dash E. The simplified capacitance Cs, one capacitance, Gm Vb dash E, R naught. Here we have GCE. GCE is going to be R naught. R naught is 1 by HOE. You have C, L, R in series, Ri. Across Ri, I'm going to take V naught. See, now see how the diagram is simplified. Okay, so input side is very, very simple. But output side, you see many components are in parallel, but only this component is odd man out because it is in series. So if I convert this LR into parallel, then everything will be in parallel and my circuit becomes very easy to analyze. So the next step what I'm going to do is I'm going to convert the series RL into parallel RL circuit. Okay, for that you see this is series. So the impedance is given by R plus j omega L. If you take the admittance is 1 by R plus j omega L. So if you want to remove the imaginary term, the denominator, you multiply and divide by conjugate. So I am multiplying and dividing by the conjugate of R plus j omega L, which is R minus j omega L. So R minus j omega L divided by R plus j omega L into R minus j omega L. And a plus jb into a minus jb is a square plus b square. So the numerator will be same, r minus j omega L by r square plus omega square L square. So divide each term, r by r square plus omega square L square minus j into omega L by r square plus omega square L square. So I'm denoting the first term as 1 by rp and the second term as 1 by j omega LP. Because you know admittance, if you take, I cannot it as RP. Admittance means it is conductance, right? So first term will be 1 by RP. Second term will be 1 by j omega LP. So if you equate it like that, compare the terms, RP will be this term. The reciprocal RP will be the reciprocal of this R square plus omega square L square by R, and LP will be the reciprocal of this R square plus omega square L square by omega square L. Why we are deriving this step is I am going to convert my series RL into parallel RL circuit. So I want to find what is the parallel resistance and inductance in terms of R and L. So you cannot just like that put this series RL into parallel RL because the values will change. Just like that Portnona, we can do it immediately, right? We didn't immediately decompose the series RL into parallel RL because the values will be different in series and parallel case. So I am just finding out the values of R and L in parallel. Then I am going to replace the series RL by parallel RL circuit. And you know the quality factor is given by omega naught L by R. So we are going to simplify, see omega naught L by R, and in the expression for RP you see it is this one. So take R as common, so R into R plus omega square L square by R. So you can cancel this R, so you get RP equal to R plus omega square L square by R. So when you compare omega square L square by R, this R value is very, very small. So I can write RP is approximately equal to omega square L square by R. The inductor ID, practical inductors will have this resistance, but the resistance value will be very, very small. So when you compare the first and second term inside the bracket, the first term is very, very small, the second term is very, very big because the frequency is high frequency operation. So omega will be very, very large. So when you compare the first term and second term, first term can be neglected. So RP is approximately equal to this term, omega square L square by R. And when you take LP, R square plus omega square L square by omega square L, divide each term by omega square L, you will get R square by omega square L plus L. And when omega is very, very large, the first term will be almost zero because 1 by omega square. See, omega itself in megahertz. So omega square will be 10 power 12. So 1 by 10 power 12 can be approximated to 0. So LP will be approximately equal to L. So these are the simplifications we do when we convert the series RL into parallel RL. Remember, you cannot just like that change the series RL into parallel RL because the values will be completely different. After approximation, you can find the inductor value is same, but the resistance value is not same. It is omega square L square by R. So remember, this formula has to be applied for converting series RL into parallel RL. Now hereafter we will draw only the output side because input side is almost fixed. Input side is almost fixed and in standard form only. Output side I'm going to measure V out, right? So I'll be focusing more on the output side.